By calculating this 18 kilowatt, I'll design the solar electric panel into the AutoCAD drawing accordingly. So for 18 kilowatt, I will design the solar electric panel. To design the solar electric panel, we required the multiple components. Solar PV system includes different components that should be able to select it accordingly to your system types, site location and the application. The major components for the solar PV system or the solar electric panel are the below. The important components required for the solar electric panel is PV modules, or it is also called solar photovoltaic modules. Solar photovoltaic panels. Solar photovoltaic panel made out of cells which takes the sunlight and convert that sunlight into the electric power. So the PV modules is a very important part of the solar panel system. Solar PV modules convert sunlight into DC electricity and current coming from PV panels. The next important part for the solar electric panel is solar charge controller. Solar charge controller regulates the voltage and current coming from PV panels going to the battery and prevents the battery overcharging and prolongs the battery life. That's why we require the solar charge controller. The third main important part in a solar electric panel is the inverter. Inverter converts DC output of PV panels or wind turbine into a clean AC current for the alternate current appliances or fade back into a grid line. It means the inverter is the important part which converts your DC output into the AC outputs. That's why inverter is a very important part. The next part is the battery. Battery stores the energy from supplying to electrical appliances where there is a demand. It means when there is a demand by the appliances or by the any flat, the battery gives the power to that particular appliances. So the battery is important, and the design of battery bank is also important in case of solar electric panel design. So these are the four main important parts required for the solar electric system design. Now by this we need to calculate we need to determine the power consumption for the entire building. The first step of designing a solar PV system is to find out the total power energy consumption of all loads that need to be supplied by the solar PV system, so that I have calculated this power demand into the Excel sheet. The total demand for the entire building is 18 kilowatts. So I need to design the solar electrical panel which provides the 18 kilowatt energy to the entire building. For that, I need to design the solar electric panel. For example, the solar electric panel has the standard size of the solar electric panel is 77 inch to 39 inch. 77 inch is the length, whereas 39 is the width of solar electric panel. 77 is approximately 2 meter and 39 inch is approximately 1 meter. So I will design the solar electric panel into the metric system, that is 2 meter length and 1 meter width. So this is a typical solar power panel. This solar power panel provides the electricity of around 450 watts. It means one power panel provides the 450 watts. So if my entire kilowatt is 18, my entire power requirement is 18 kilowatt, what I require is the 18 1000 divided by 450. So 40 arrays what I required to the entire building. It means 18 kilowatt into 1000, that is the 18,000 watts. So this 18,000 watts total energy required, or the total electricity required for the entire building. So what I required is the 40 panels on each grid, so that the 18,000 is there and divided by 450. So I required 40 panels to create the entire 18 kilowatt energy. So this is what I am doing. I need to assemble like this. This is entire 4 panel is there, and I need to draw the 10 column and 4 rows, so it will become the 40 panels. So these are the 40 panels for the entire building, so that from here to here there is the total length of the building must be more than 20 meter, so that the panel can be arranged accordingly. So this 450 watts each panel multiply by 40 creates the 18,000 watts, that is 18 kilowatts. So this entire system gives the 18 kilowatts power. It can be divided into 2 part, 3 part accordingly as per our requirement, so that it can be there must be the space between these two, or it can be arranged typically so that it can be space saving. So from there I will design the power generation cable from here to the inverter. So there is the inverter, or in between the inverter to the PV modules. This is the PV modules. I have arranged this PV module as per requirement. From the PV modules here, so from the PV modules the cables goes to the solar charge controller. So I will draw here the solar charge controller cable. One is the supply and one is the return. So the cables is like this. The controller cable required for the solar electric panel. So here is the solar charge controller. This is the solar charge controller. The solar charge controller takes the command. The solar charge controller regulates the voltage and current coming from the PV panels going to the battery and prevents the battery overcharging and prolongs the battery life. So that command is each power saving into the inverter must be come from the solar charge controller. From the solar charge controller there is the cable like this.